All right, so these are our very last calculus notes of the year. That's exciting. So the shell method, section 6.3, I think this is actually easier and less time consuming than the disc and washer method. So hopefully this will go quicker. So for example 1, if you guys already watched the Professor Dave video and the other video, I thought they did a great job of explaining why this works and how the formula is derived. But if you don't have this formula written down somewhere, you're going to want to write it down. So volume equals from A to B 2 pi x times f of x and then dx, if we're in terms of x. Okay, and you do this when you're rotating around the y-axis. That's a little bit backwards of what the rule was last week in section 6.2. So a way that I thought that was kind of interesting, this is like this, it's like a volume of a cylinder where you guys know this is a circumference, this function is the height, and then the dx, that's the thickness. And if you kind of keep doing these cylinders over and over where the thickness like kind of approaches 0, that's how we're going to find the volume. So for this particular problem, f of x is 1 over x. This is your a and your b, and that's basically all you need to know. So we're going to say volume equals the integral from 1 to 3, 2 pi x, f of x is 1 over x, and then dx. So we plug that in. Remember, we're integrating in terms of x, so anything not involving x we can pull out front. So 2 pi from 1 to 3. And then what happens when you multiply x times 1 over x? You just get 1 dx, which is weird. When you integrate 1, it just turns into x. So we're going to evaluate x from 1 to 3 and multiply that by 2 pi. So we're just going to have 2 pi times 3 minus 1, or 2 pi times 2, and we get an answer of 4 pi. So that's the answer for example number 1. Okay, example number 2, so to help visualize, you guys know x squared is just a basic parabola. We want to evaluate from 1 to 2, and then it's kind of like imagine this rotating around. So you could do the washer method, but it's just kind of annoying doing the washer method. But it's kind of like this cylinder inside is blank or it's empty, and the shell method is going to get us our same results. So remember, volume a to b 2 pi x times the function f of x times dx. All right, so our a and b, remember, since this is dx, we want to use our x variables. So we're going to evaluate from 1 to 2. 2 pi x always stays, and then our f of x is just x squared dx. All right, let's pull the 2 pi out front, and let's go ahead and multiply our x and x squared. Now when we integrate x to the third, we get 1/4 x to the fourth. We're going to evaluate that from 1 to 2, and we're going to multiply that answer by 2 pi, leaving us with 2 pi times, if we plug 2 into this, we get 2 to the 4th times the 4th, which is 4 minus 0.25, so 3.75 times 2 pi. And if we want to put that in fraction form, it would be 15 pi over 2. If you want to leave it in decimal form, that would be all right as well. All right, here's example 3. We have a parabola here, 2x minus x squared, and it's bounded below by the x-axis. That's just like saying, you know, this line right here. That's why this part is shaded. And we now are going to rotate. Oh, we're still rotating around the y-axis. You can see that from the picture. All right, so let's go ahead and find the volume. So we're going to go from 0 to 2. They tell us that there. We also could know, because if you just evaluate this parabola, this point right here is 2, 0. So they don't really have to even tell you that we're going from 0, 0 to 2, 0. That's why it's from 0 to 2. Okay, so that's why it's this. 2 pi x times the function, 2x minus x squared, dx. 2 pi pull out front. And now I'm going to distribute this x into the function. So it'll become 2x squared minus x to the third dx. And when we integrate that, we're going to get x to the third, and that would be 2/3 x to the third minus 1/4 x to the fourth. And we want to evaluate this from 0 to 2. Notice when you plug 0 in, this will just be 0. So all you have to really do is evaluate this at 2. So 2 pi times 2/3 times x to the third would be 16/3 minus, if you plug in a 2 right here, it'd be 1/4 of 16, which is 4. And then we would go ahead and figure out that you can figure this out, that it's 8 pi over 3. Okay, for example 4, I want you guys to change this a little bit, and then it matches up with one of the videos that I sent with you guys. So question number 4, if you change it to y equals x squared, y equals 0, x equals 2, and then we'll scratch out this. It's still going to be, you know, a parabola, but the difference with this problem is you're going to rotate it around the x-axis. And in the video, they do this problem, but they find the area of this white region. Since we were bounded a little different here, that's fine. So I want you guys to try this one, submit this one as part of your homework. In the video, they're going to find this white region. Just by basic math, you guys should be able to figure out what this whole region was and then subtract to find the missing cylinder region. So this number 4, we'll say this is part of your homework.